might have heard it with some industrial perspective or so on. So what is the topic or the subtopics that we are going to learn into this? Let us go through one by one. We are going to study the definition of grinding, the elements of grinding process, the various elements. Then we are going to study the work, that means the work material that is used for grinding. Then we are going to have the wheel which helps for grinding, the machine. Then we are going to study the classification of grinding machines. Different types of grinding machines are available, wherein we can have these types available based on the configuration, based on the process, based on the different kinds of operations that they perform, and so on and so forth. So then the classification, followed by the classification, you have to study the mechanism of material removal in grinding. Mechanism of material removal. So how the material is removed from the workpiece by using the grinding wheel. So that we are going to study. Then a specific feature of grinding, that is self-sharpening characteristics. This is one unique feature of this tool, that is, we call it as a grinding tool. So we need to understand what is that self-sharpening characteristic of this grinding. Then we are going to study different types of grinding machines or grinders. Next in the line we have specifications of a grinding machine. Followed by this we have the construction of grinding wheel. See, for us this grinding operation may be very simple, but if you see in detail or if you specifically see the characteristic or the features of a grinder, it is very complex. It consists of so many elements. That is why we need to study the construction of grinding wheel. Next, we have, as a component of grinding wheel, we have the different abrasives. Abrasive word I hope you people have heard many a times. Abrasives which actually perform the grinding operation. Then we have the bond material. The bond material is nothing but the one which holds the abrasives. And next we have the marking system. So this is what you people are going to study for your grinding machines topic. Of course, all the topics here are seem to be theoretical. Yes, purely this unit number 5, comprising of grinding machines as well as CNC, completely they are theoretical, and hence I wish to take up the chalk and talk method for the first 2 or 3 classes, and in the last 2 classes we will switch on to the PowerPoint presentation, wherein you can go through the different videos, how actually the grinding happens, what exactly is that process, and so on. So let us first understand the theory behind it, and then we will go for the practical examples through the video lectures. So these are the things that you are supposed to study for your grinding. From the examination point of view also, you have the syllabus that has been framed with regards to this. So if you want, you can just make a note of this so that we can take up one by one the elements or the topics. Okay, so let us now start with one by one understanding these topics. Well, we'll start with this. I wish to write down some specific points which you are supposed to remember. What we expect as you people are engineers now. You people have been shared with the notes. People have the textbooks. So what we will do is we'll take a topic and write down the key points into it, and you can convert those key points into sentences for your examinations, right? So let us understand from the first, what is this grinding? So basically, if you see, grinding is a finishing or super finishing process. You can say it as finishing or finish or super finish process. What do you mean by finish? Let us take an example of this bench, or you can take the example of this podium. Now if you see, the surface of this podium is very smooth. Why it is smooth? It is because of that plank or a sheet of wood that has been put over here. We call it as laminate, which has been put over here. Okay, so the surface is smooth. The smoothness is a term that is referred to with regards to your finish. Why finish? Finish means it is the final work that you do onto a component. Now if you see, in case of metal cutting, in the earlier types of metal cutting operations like milling, drilling, lathe and so on, there also finish was very important. I hope you people remember we were discussing when we were taking earlier topics like at high speed you get a smooth finish. Okay, we were discussing those. So now here the finish is very important, and the finish that we can obtain by grinding is much superior than that which we can obtain through the earlier processes. So let us understand the definition of grinding. So grinding is defined as a metal cutting operation in which material is removed by bringing in contact an abrasive wheel with the work. You have an abrasive wheel onto which you have stuck the abrasives. What are abrasives? Abrasives are nothing but number of cutting tools, small particles which are having sharp edges, which are stuck all around the periphery of that wheel, and that wheel is brought in contact with the tool which you want to grind or sharpen or produce a finish over it. The best example that you can relate here now is the single point cutting tool that you people use to sharpen. You used to take that single point cutting tool to the grinding wheel on the machine. You take that tip, nose, rake angle and so on. Those can be produced by using that grinding wheel. So you used to take it and link it or make it to you used to bring it in contact with this wheel, and that wheel which is rotating at a high speed used to sharpen the tool. Also you might have seen there may be some sparks that might be produced. That is because of the rubbing action, friction that generates heat and also sparks, right? So that is what is the best example of grinding. Now what are the specific features of this grinding? Let us list a few of them so that you people can understand it much better. Okay. So this grinding basically produces the chips of 0.25 to 0.50 mm. This is the chip size of the grinding. So when the tool is brought in contact with the work and fine chips are produced, the size of those chips are so small. You remember the chips that are produced in case of lathe, milling and drilling. Generally they are long chips, okay, but these are very fine chips, right? These are finer than milling chips also. If you compare, the chips produced by lathe are in a helical or a coiled fashion. You discussed regarding the continuous chip, discontinuous chip, built up edge and so on. Similarly, when you go to drilling also, they are slightly longer. you have milling, smaller chips, but grinding, you have still finer particles. That is, the size is 0.25 to 0.5 mm. Next, speaking about the accuracy. Accuracy of grinding operation is up to 0.000025 mm. This much accuracy can be achieved. Then what is the finish that you obtain? The surface finish that you can obtain by this grinding is nothing but 1.25 to 0.25 micrometer. This is what is the surface finish value that you can obtain. So high finish can be obtained by using this operation, right? Next. However, even though you have this grinding, which is a super finishing operation, sometimes you will not get the smooth finish as you require. For some high-end applications wherein a component is going to fit into a unit or fit into an assembly, there we need fine finish. For those operations or for those applications, we have advanced super finishing operations. Just I will keep you informed regarding this advanced super finishing operations, which we call it as lapping and honing. These are the two words you are supposed to remember for advanced super finishing operations. Okay, so these are the advanced versions of finish operations, which are nothing but lapping and honing. Now, let us go to some more specific features of this grinding. So what happens basically in a grinding? Let us focus more on this grinding operation. Let me draw a sketch wherein you can understand the principle of grinding. This is the workpiece. This is the workpiece. You have this as your grinding wheel. Okay, let's draw a section of it. Let's take a part of grinding wheel which is actually taking part in the cutting action. Then you have onto this wheel the abrasives which are stuck, or you have them fixed. You can see that the abrasives have been stuck well by a bond. That's why those terms bond, abrasive, adhesive, and so on we will be using. So this is the abrasive that is actually doing the cutting operation. The wheel, of course, will be in rotation, right? So when this wheel is continuously rotating, just imagine and think about that grinder which you people used to utilize for sharpening your tool, or the non-teaching faculty used to sharpen the tool and help you all to conduct the lathe process in a better manner, because the tool gets blunt generally whenever you have used it for a longer time. So he used to again sharpen it and provide it to you. Now let us see, take this. So this is what is the grinding wheel. Next we have this as the workpiece. The workpiece is of course fed against the wheel, then only the cutting action is going to happen, right? Next you have these as projecting grains. I will tell you what is that. Grains. So what are these grains? These are abrasive grains which are stuck onto the surface. Okay, so this is a typical concept of grinding operation, you can say, wherein you have a grinding wheel. All along its periphery, circumference, there will be a strap, or you can say the abrasives will be stuck all along the surface. It will be entire surface. This is a wheel. You people are seeing the side view. Okay, so this is the wheel, the shaft. All along its surface you are having the abrasives which are stuck around its periphery. Now another example how these abrasives are stuck The best example is you can take your sandpaper. On your sandpaper, there are sharp, fine abrasive particles which are stuck onto its surface. So whenever you want to clean the paint and all, you take it and just rub it. So what will happen? The sharp abrasive particles which are there onto the surface of the sandpaper, these particles are harder and stronger than the paint layer. Hence they abrade. Abrade means they help in removal of that layer of the paint. That is how happens. Similarly, here these abrasive particles are still stronger than the metal itself, so that because of the hardness, sharpness, they will help in removing the material from the workpiece. So if you give a rotation clockwise, you can observe that fine particles from the surface are getting eliminated, or the chips are formed. Means the material is removed. Can you see? This was initially a slab. From the slab, we have removed this much amount of particles. How? By abrasion, right? So you can see layer by layer, further the material will be removed. I am showing it with dotted lines so that you can just understand. So this is the grinding wheel onto which the abrasive particles are stuck. On to this, when it is brought in contact and fed against the workpiece, what will happen? Material on the surface of the workpiece gets abraded, finer particles are removed as chips and are thrown away. So you can show the chips which are thrown away here. Okay, now so let us have the understanding of this. So you understood that because of this, the concept of grinding here implies that when you bring this abrasive wheel in contact with the workpiece on its surface gets abraded by the particles. So there is a there is an interaction between the abrasive and the workpiece in such a manner that fine particles are just thrown off away from the surface of the grinding wheel, and powdered form of chips are collected or thrown at the other end. This is what is the concept of grinding wheel is. Now some specific features of this grinding which you can remember is as follows. The projected grains are held on board. What do you mean by this? So the projected grains, these grains are held by a strap or a board which is fixed onto its surface, right? Next. Second point, grains remove material in form of small chips, same like milling. Okay, these grains abrade means they pluck into the work surface and remove a part of the work, that is abrade, and they can produce the small chips. Next, this operation of material removal is intermittent in nature. This operation is intermittent. What do you mean by intermittent? Not continuous. Particles are removed, again a small gap, again next particle is removed, again small gap. Intermittent, because finally this tool, a grinding tool, is a multi-point cutting tool. You can see so many grains are stuck onto the surface. Each grain here acts as a single point cutting tool. Hence, overall the material that is removed is in significant volume. Okay, so that each grain acts here as a single point cutting tool. So operation is intermittent in nature. It's not continuous. Small gap, because you can see there is small gap between two abrasives, right? Next, most important, it produces discontinuous chips. Of course, since the operation itself is intermittent in nature, it produces discontinuous chips. Next, geometry of the grain is random. Geometry of the grain is random, so that you have a kind of operation wherein the grain geometry, the particle shape size, it's random, because you know when you have finer particles, when you crush them, you can't exactly predict they are of a particular shape. So they are pointed structures, but they are random structures. Next, what about the load acting on each grain? There will be a sufficient load that is acting on each grain. So what kind of load it is, whether it's uniform, non-uniform, how, and also it depends on how many grains are there in a particular section of the wheel. That also matters. So the grain, the load acting on grain is non-uniform. It is non-uniform. Non-uniform grain. Okay, non-uniform load is acting. Next, time of contact. Time of contact between chip and the abrasive is small. For a very small instance, the abrasive will prick or remove the material in the form of chip and will pass off. Lastly, what about the temperature? See, if you have seen, again to repeat, if you people have seen during the sharpening of the tool, you remember that you have sparks that are generated. Why the sparks are generated? Because of the extreme high temperature that is prevalent in between the work and the tool. Hence, we can note down that point, the temperatures that are generated. So, high temperature up to 1000 degrees Celsius are prevalent. Of course, this again depends on the material, ductile material or brittle material or hard material, soft material and so on. But generally, the temperature is as high as 1000 degree centigrade, right? So, these are some specific features of grinding as well as the specific things that you are supposed to remember in case of grinding. So, of course, this diagram you people can draw in order to explain the concept of grinding, and you people can explain it in your own words. However, the technical details need to be mentioned. So, what are the technical details that you are supposed to mention over here are nothing but these things. So, let me quickly revise what we have done. So, grinding, basically grinding is a metal cutting operation, which we also call it as a finishing operation, utilized to remove the material from the work surface in the form of fine chips by bringing an abrasive wheel in connect or contact with the work. So, what happens between the abrasive wheel and the work? There is a rubbing action, friction is generated, and the abrasive particles, which are sharp in nature, prick the material. They prick the material and remove it in the form of fine chips that are thrown away. So, please remember, the wheel is rotating at a high speed, the work is fed against, so it is clockwise rotation and the work is fed against the wheel. This is a typical scenario for up milling, if you remember, because in up milling also you people were having these grains, were having the rotating cutter, that is milling cutter, which had multi points of cutting that used to pluck. Okay, and also we discussed in that regarding the thrust force, it will try to lift the component, but here you can have a benefit of feeding the component in a required manner, right? So, you yourself might have observed, in case if you have sharpened that single point cutting tool, you may feel a backward thrust. It will try to push you back because of the high speed with which it is rotating, right? So this is the concept of grinding. So you can mention this, already I have told, concept of grinding. So how grinding takes place? So the specific features like the projected grains or the abrasives, we will study in detail about the abrasives, what they are actually, how they are, and how the bond is holding the abrasives at a place. All these things we will see later. But we can observe here the salient points, that is the projected grains are held on board, the grains remove the material in the form of small chips, operation is intermittent in nature, then this grinding operation produces discontinuous chips, geometry of the grain is random, you cannot predict the exact shape of each abrasive particle because thousands of abrasive particles are there all along its surface, right? Next, load acting on the grain is non-uniform, time of contact between the chip and the abrasive is very small. For a small instance, the abrasive will prick and go to for the rotation. Like each time that particle will again take part itself in plucking the material. Why? Because you also have a feed. It will go on feeding, it will rub against. It's like sandpaper you take and just try to remove the paint. Okay, if you just scratch it on your fingers, you will bleed, right? So that is how the abrasives work. Okay. Next, the high temperatures. Because of this rubbing action, there is high temperature that is prevalent at the work tool interface. Also, another point I wish to tell here, that if you want, then we can have a coolant supply at the juncture of this wheel and the work. You can have a pipe. Okay. Also, you might have seen this grinding operation while you are passing near those outside lanes or in the area of Udyam Bagh. You might have seen this. So you have the coolant which will be supplied onto the interface of the work and tool. You can have a pipe, you can just supply the cutting fluid, which we call it as cutting fluid, can be supplied in order to minimize the heat generation and obtain a still better surface. Okay. So this is what is the concept of grinding operation. Okay. Now let us slowly switch or move on to the classification of grinding machines. So in all grinding machines, any type of grinding which we are going to see now, the basic principle of material removal remains the same. This is how the working principle of grinding is. Let us take up the classification of grinding. Okay. Let us note down the classification of grinding machine. This is, please remember, classification of grinding machines. So based on two types, the classification of grinding machines has been decided. So what are those two types? Let us list and note. First one, according to the quality of surface finish. Okay, so first classification is according to the quality of surface finish. Then the second classification, let me take it up here. According to the type of surface generated or work done. Okay. Now, this is further classified. This is the main broad classification, that is according to the quality of the surface finish, and the second one according to the type of surface generated or work done. The further classification of this goes like this. One is roughing operation, or we call it as non-precision grinders. In this, there is first case, second case is precision grinders. This roughing or precision grinding and non-precision grinding, these are the two sub-classifications in your according to the quality of surface finish. However, further, this roughing or non-precision grinding operations are further classified as bench. You people have heard bench wise, so it is bench or pedestal or floor grinders. Second, swing frame grinders. Portable or flexible shaft grinders. Now, this classification itself, the naming itself makes us understand that it is very specific to the quality of surface finish. You might have observed sometimes the laymen or the working people at the sites, construction sites and all, they use a hand grinder. They just tilt and twist and keep grinding the surface, right? Polishing or grinding. Generally, they have a flexible grinders. So that is why the words bench, pedestal or floor grinder refers to that the grinder is fixed onto the bench. Then we have the swing frame grinders, wherein you have the frame or the shaft which can swing. Okay, you can have a swing and you can do the grinding operation. Next, third one, portable or flexible shaft grinders. Portable, so you have portable hand drill which we have studied. Similarly, you can have a portable grinder, right? So those are the three types of rough or non-precision grinders. Please remember, these are rough grinders. The surface that we obtain is not very fine. It is rough grinder. Next is the precision grinders. So precision grinders, we have the specific types which we will take up. Not specifically they are classified. Precision grinder means you have a very good finish, precise. They are in a operation. Okay. Next part, that is according to the type of work done. Now here, according to the surface that is generated or the work done. So we have again the three types. Type 1, cylindrical grinders. Second one, internal grinders. Third one, surface grinders. Okay, so we have three types: cylindrical, internal, and surface grinders. These are further classified as follows. This plain cylindrical grinders. Second one, universal grinders. Third one, centerless grinders. Again, similarly, you have three types for internal grinding or internal grinders: plain internal grinders, universal grinders, and the third, centerless grinders. Okay, so these are the three types in each: cylindrical and internal. The third one, surface grinders. Generally, you see, for a larger application in the industry, surface grinders are very popular because they are used to smoothen the surface, produce a finish which is required. So the third one is surface grinders. So in this you have two types: reciprocating table grinders, and rotating table grinders. Okay, so you have reciprocating table grinders and the second one is rotating table grinders. So you have these. So a broad classification of grinding machines can be noted as this. So you have the different types. Let us begin from the first. So we have, according to the surface finish, if you want a very fine surface finish, much better surface finish, we can go for precision grinders. If you are okay with the surface finish, if you want the material to be removed, that is your main objective, we can go for roughing or non-precision grinders. In that we have the three types, that is bench or pedestal floor grinders, swing frame grinders, and the portable or flexible shaft grinders. In the other case, that is precision grinders, these are used for high precise operations. Suppose you have very small component and you have to do the grinding, or the finish you need is very smooth and you have to do it very delicately. You have to do it with caution. So you have to use precise grinders. Precise means exact. What you want exactly, you need to achieve that. That is precision grinders. The next category, according to the type of surface generated or work done. In this again we have the three types. One is cylindrical grinder, the second is internal grinder, and the third is surface grinders. So in this again, if you observe, you have three types in cylindrical: plain, universal, centerless. Second, internal grinders, again in that three types: plain, universal, centerless. And the third, the surface grinders, that is reciprocating table and rotating table. So in this we can understand that what is that reciprocating table and rotating table. So reciprocating table means you have a grinding in which you have a table onto which the workpiece is mounted. So the table is continuously reciprocating. So it will move from one end to the other and reverse, or the reverse path. So that is reciprocating. You know reciprocating motion. So in that way the grinding wheel is fixed from the top and this will be reciprocating, and the grinding wheel is brought in connect with it, right? So the material is removed. So rotating, you have a rotating table on which the grinding can be performed. The workpieces can be fixed at different places. So that is what is the classification. Okay. Okay, so this is what we will have today, and some more specific features I will just discuss, and will end up today's class, so that fresh we can start tomorrow the self-sharpening characteristics of a grinder. So we discussed regarding that self-sharpening characteristics. So let us understand what is that self-sharpening characteristic, which is a unique feature of grinding and is not available in milling and drilling or lathe. Okay, so let us take some more interesting concepts with regards to this grinding. Just note a few. Okay, so some more features which we can note specifically. We have discussed this, but just specifically mentioning the wheel of the grinder are attached with abrasive grains. Each grain acts as a single point cutting tool. Third is, we need to understand what is bond. What is bond? Bond is nothing but it is an sticky substance which will hold these abrasives firmly at a place and keep them together. So bond. So bond holds all the abrasives together firmly. It holds all the abrasives together firmly, and so many abrasives are there. So there are more than thousands of abrasives in one wheel, because they are very small. Projecting particles are very small. So you can imagine over the entire surface. I will show you once we switch on to PPT. You will be able to see the video of that grinder. Of course, you have seen so how those abrasive particles, rough surface, that abrasive particles are stuck onto the surface. They are held firmly. Of course, the bond is very strong. It has to hold all the abrasive particles very firmly, rigidly, because you know the force that it has to withstand. This one is rotation, another is it has to press against the work. So it matters. So the bond has to hold all the abrasives together very firmly. Next, what is the speed with which the wheel rotates? The speed of wheel rotation. It is almost 75 meters per second. This is again the speed with which the wheel will rotate. Okay, the linear speed that we have taken, so it will be at 75 meters per second. This is for a particular wheel. It is not common for all, but it's for a particular wheel. Next, most important thing is high cutting speeds are involved. Okay, you have also seen the speed of cutting, metal cutting during lathe and drilling. It's at a low speed, right? You people remember the difference between the cutting speed and the spindle speed. Okay, so most important relation. Okay, so here the cutting speed for grinding is much higher than for your lathe, okay, or drilling and milling. Okay, so now at high cutting speeds, what happens? The section of chip removed is small. At high speed, smooth finish, small chips. At high speed, and hence excellent surface finish. Is obtained because the speed is high. You will get very good surface finish and also high accuracy. High accuracy, right? So these are some of the specific kinds of features of grinding wheel, okay, and the grinding process. So I think we can wind up today, and we will see that we will continue with the next units or the next subtopics. The next subtopic which we are going to study is nothing but the self sharpening characteristic. Followed by that, we have the different types of grinders. So you have surface grinder, cylindrical grinder. In cylindrical grinding, you have different types. Again, you have the centerless grinders. Okay, so three types you are supposed to remember. One is surface grinding, then you have cylindrical grinding, then you have centerless grinding. So these three are there for you all. So sketch, explanation, principle of working, and application. All these you are supposed to remember for the grinding. Now, along with this, so this is for today. We will take up the next part in the next class. That is tomorrow morning. We will take up. Now, I just wish to tell you people some few important things. That, of course, we have a very big gap. Okay, because of this lockdown and all. See to it that you revise all the things properly for your examinations, and also for your second IA test. We are going to share the syllabus very soon, and we will keep you updated on the WhatsApp as well as the details. But from your final examination point of view, see to it that you practice all the problems that are there in milling also. I think I had shared with you all one video in which we had explained about the simple indexing, the concept of simple indexing. You have to remember the theory as well as the numericals, and also the compound indexing, because you may have numericals on simple indexing as well as compound indexing. So both you are supposed to be perfect with regards to those. Okay, and next is the numericals with regards to your late chapter. Okay, practice them. You can take some textbook. Okay, also refer to the notes of both the divisions. Like A division can refer B division notes, B can refer A. The varieties of problems you may get, practice them, and also the problems on the relevant problems in drilling or your first unit, that is theory of metal cutting. There also we had problems. Okay, like cutting force, thrust force, and so on and so forth. and if time permits, let us see how it will be. So after finishing this grinding machines and CNC, if we get 1 or 2 classes, let us see, then we may just quickly revise those problems. Okay, let us see. I will solve some 1 or 2 problems, 2-3 problems, so that you can refresh. Okay, but the basics, the fundamentals, you have to make it for yourself strong, because one point is your academics, which you will be completing your SW and so on. The second point is tomorrow in your career, if you switch on to this metal cutting sector or industry of metal cutting, then you need to know all these basics. Also from your placement perspective, in placements they may ask any question like this. Okay, so based on the operations, the technical features, what are the different specifications, and so on and so forth. Okay, and make a point that in case you get a chance to visit any of the machine shops nearby, because Belgaum area, this Udyambag area is full of machine shops and castings and forming and metal cutting, everything is available to you. Okay, so if you get time, or if you have some industry which is known to you, you have your relatives, friends and so on, make a small group, go there, visually observe how the process happens, and just enhance your knowledge, because that will help you now or further, somewhere it will help you. Okay, so this is what is I wanted to convey to you all, and keep working. Okay, don't be lethargic and sit idle thinking that we'll see at the time of examination. No, things won't work like that. Even though from an examination point of view, you should study, yes, definitely, but also from your future perspective. Okay, you have to work hard. Things are not as easy. People are not getting jobs. You have to compete with a bigger world. You have so many challenges that you are supposed to face. Hence, see to it that you people make your basics strong. Fundamentals should be strong. If your fundamentals are strong, you can enhance it and learn new things. You will have that tendency of learnability. Okay, so you have to develop that tendency of learnability. So see to it that whatever we have taught, okay, Anand sir has taken, AAK sir has taken the initial few chapters. I took over with unit number 4, milling. We studied that milling types of milling, operations in milling. So everything, you keep all the notes at a place systematically. If you don't have notes, you can prepare notes. That is what the reason we are giving it in the form of points, so that you can remember it. If we give it in the form of sentences, long sentences, you may feel it little cumbersome. So that's why I generally prefer to jot these points onto the board, so that you can note them down and convert these small bits into sentences and explain. So from the final examination point of view, you can draw one neat sketch. Sketch should be neat. Please scribble it. Don't draw it haphazard. Draw a neat sketch systematically with these 5 to 6 points. That will fetch you full marks. Systematically you write. Okay, just convert these into sentences, or even if you write these specifications or details, also it's enough. But you have to represent it systematically. So suppose if it is asked, for example, explain the concept of grinding for 6 marks. It is expected as a teacher that you are supposed to draw a neat diagram, which will fetch you 3 marks. Okay, the drawing of the abrasive, grains, wheel, the workpiece, and show the directions. Please remember, the directions are very important. Rotation of the wheel and movement of the workpiece, the feeding of the workpiece, both are very important. So you see to it that you draw that sketch systematically and write few bits. As I had written some points over there, write them as it is. Also, it's okay, and you will get maximum marks. Okay, see to it that you are engineers and you have to represent in a better way. Okay, we expect that from you all. Fine. And also, if you want, I think the textbooks that we are referring, however, we have shared with you all. We will share with you whatever we are utilizing for these classes, and don't have any kind of a worry that how you will be able to cope up. Definitely it's possible. In this digital world, you people have to accustom and adjust yourself to this kind of teaching, right? So we are with you. Any doubts, anything, please connect to us through WhatsApp, okay? And just send a message that you have some doubts, Let us see if many people have a common doubt in our last classes. We can revise those classes. Okay, we can revise the concepts and just take up. Is it clear? So don't have any kind of apprehension that how we will be doing, what we will be doing. No, don't worry. You have to work and positive, be positive. That is very important. Right? Now, some textbooks, as it is already mentioned here. So that is Juneja and Sekhan. Okay, then you Chowdhury, that is workshop technology. Next is HMT, production technology. Ghosh and Malik. Then fundamentals of metal machining and machine tools by Boothroyd, and so on. Some textbooks are there. But however, what I personally feel is, if you are comfortable with these notes and the theory that is taught to you, and systematically if you have preserved all the notes, that is sufficient from your examination point of view. However, to enhance your knowledge, you can refer some textbooks. Okay, you can go through the textbook, and for problems, definitely yes, for numerical problems you are supposed to study the textbooks and you have to practice the problems. Okay, don't simply remember the steps, practice them. Close the book, take a problem for compound indexing and try to solve it on your own. Okay, and then you will be perfect. Is it clear? Okay, then thank you for today. We will meet up tomorrow. Okay, thank you.